January 26, 1943, room 3327, New Yorker Hotel, Manhattan. The physicist stopped counting at item 47, overwhelmed by the sheer volume of technical drawings scattered across the floor. Dr. John G. Trump, MIT professor and consultant to the National Defense Research Committee, had been summoned by the FBI with explicit instructions: determine if the dead inventor's papers posed a national security threat. The hotel manager stood nearby, perspiring despite the winter cold seeping through the window. On the bed lay the documentation for what newspapers were calling the most dangerous weapon ever conceived. What Trump didn't know, what nobody in that cramped hotel room could have imagined, was that he was examining the culmination of a 30-year obsession that had consumed not just one eccentric genius, but dozens of inventors across 3 continents, all chasing the same impossible dream: the death ray. A weapon that could shoot down aircraft at 250 miles, incinerate armies, and make war obsolete. It sounded like science fiction, but between 1923 and 1945, some of the most brilliant minds in physics had staked their reputations on making it real. And for a few terrifying seconds in a laboratory in England and later in a bunker outside Frankfurt, it actually worked. The story begins not with Nikola Tesla, but with a charismatic English inventor named Harry Grindle Matthews, who on April 26, 1924, stood before representatives of the British Air Ministry and demonstrated something that shouldn't have been possible. Matthews, a 37-year-old veteran of the Boer War, twice wounded, stood in his laboratory wearing a spotless white coat and patent leather shoes. The setup appeared deceptively simple. On one table, 45 feet away, sat a small gasoline engine connected to a magneto, running at full speed. Matthews positioned himself behind what looked like a telescope mounted on a wooden tripod, a contraption bristling with vacuum tubes and copper coils. He adjusted several dials, peered through the eyepiece, and pulled the lever. The engine died. Instantly. No sputtering, no gradual loss of power. One moment it roared at full throttle, the next it sat silent, as if someone had cut the fuel line. The Air Ministry officials exchanged glances. Matthews restarted the engine, stepped back, and activated his device again. The engine stopped. He repeated the demonstration 4 times. Each time, the invisible beam killed the engine at the precise moment Matthews engaged his apparatus. One official, Air Vice Marshal Sir Geoffrey Salmond, asked to stand directly in the beam's path. Matthews warned against it, but complied. Salmond felt nothing, yet the engine behind him continued to fail on command. Another observer, a young engineer named Harry Wimperis, held a neon tube in the beam. It glowed faintly, confirming some form of electromagnetic energy was present. But when they asked to examine the device, Matthews refused. When they requested that he replicate the demonstration under controlled conditions at a government facility, he declined. When they offered him £1,000 to stop a motorcycle engine outdoors under Air Ministry supervision, he fled to Paris. The British press erupted. Headlines screamed, "Death Ray Inventor Escapes to Paris," and "British Government Loses Superweapon." Matthews gave interviews claiming 8 foreign governments were bidding for his invention, that with sufficient power his ray could shoot down aircraft at 4 miles, explode ammunition dumps, and incapacitate infantry. The public was captivated. Government officials were furious. Investors obtained an injunction preventing him from selling the device. Lawyers chased his aeroplane across the tarmac at Croydon Aerodrome as he escaped to Paris, waving legal papers as his aircraft lifted off. Matthews returned within days, refusing to provide further demonstrations, but granting permission to film a dramatic presentation for Pathé newsreels. The Death Ray, released in summer 1924, showed Matthews operating an elaborate apparatus that looked nothing like what government observers had seen. In the film, rats dropped dead in cages, gunpowder exploded at a distance, and spotlights shattered. Scientists examining the footage noted multiple opportunities for trickery. The device shown on screen bore no resemblance to the simple telescope arrangement from his laboratory demonstration. The British government concluded Matthews was either a fraud or a genius who refused to share his secrets. Either way, by late 1924, official interest had evaporated. Matthews spent his remaining years on increasingly bizarre projects, including a machine that projected images onto clouds and an instrument that converted light into music. He died in 1941 in a remote Welsh bungalow, still claiming his death ray was real, still refusing to explain how it worked. But Matthews did demonstrate something tangible, even if only for a few seconds in a private laboratory. And that demonstration, witnessed by credible officials, ignited a global race to weaponize electromagnetic energy. The race intensified when Nikola Tesla entered the arena. The Serbian-American inventor, by 1934 a penniless 78-year-old living in New York hotels, announced at his annual birthday press conference that he had perfected what he called teleforce, a charged particle beam weapon that would bring down a fleet of 10,000 enemy airplanes at a distance of 250 miles. Tesla insisted his invention was not a death ray. Rays dispersed with distance, he explained, becoming ineffective beyond a few miles. His device projected particles, microscopic tungsten pellets accelerated to 270,000 miles per hour through electrostatic repulsion in a vacuum chamber. The particles would be as thin as a hair, but would deliver trillions of times more energy than is possible with rays of any kind. The New York Times published his claims under the headline, "Tesla, at 78, bears new death beam." But unlike Matthews, Tesla provided technical details. He described a system consisting of 4 components: an apparatus for producing particles, a method of generating tremendous electrical force, a means of intensifying and amplifying that force, and a unique open-ended vacuum tube with a high-velocity air jet seal. The vacuum seal was Tesla's theoretical breakthrough. Conventional particle accelerators required complete vacuum systems, limiting range and power. Tesla proposed maintaining a vacuum inside the tube while keeping one end open to the atmosphere by directing a high-velocity airstream at the tip, using a large Tesla turbine for the necessary pumping action. The accelerated particles would exit the open end at velocities approaching 1% the speed of light, carrying enough kinetic energy to pierce an armor plate or explode aircraft fuel tanks. In 1937, Tesla wrote a technical treatise, The Art of Projecting Concentrated Non-Dispersive Energy Through the Natural Media, attempting to attract serious scientific review. He sent copies to several Allied governments, including the United States, Canada, England, France, and the Soviet Union. The response was underwhelming. The U.S. Bureau of Standards rejected the proposal, stating that producing the required energy levels was impossible with existing technology. The British showed brief interest, then abandoned the project in favor of radar development. Only the Soviet Union responded with funding, paying Tesla $25,000 in 1935 through the Amtorg Trading Corporation for detailed specifications, though whether they built anything remains unknown. What set Tesla apart from other death ray claimants was his insistence that the weapon existed not on paper but in physical form. At his 1937 birthday press conference, when asked about progress, Tesla stated emphatically, "But it is not an experiment. I have built, demonstrated, and used it." He claimed the blueprints existed nowhere but in his mind, that his room had been entered multiple times by agents attempting to steal the plans, and that they had left empty-handed because nothing was committed to paper. This claim haunted Allied intelligence services as war approached. If Tesla genuinely perfected a particle beam weapon, and if Nazi Germany obtained the technology, the strategic implications were catastrophic. When Tesla died on January 7, 1943, the FBI moved immediately. Within hours, agents from the Office of Alien Property Custodian secured his hotel room, but they arrived too late. Sava Kosanovic, Tesla's nephew and the Yugoslav ambassador to the United States, reached the hotel first. He convinced the manager to open Tesla's safe, removed several documents, including a memorial book from Tesla's 75th birthday, changed the safe combination, and departed. When FBI agents arrived, critical papers were missing. A black notebook Tesla kept, marked Government in several sections, had vanished. 3 days later, FBI Director J. Edgar Hoover brought in Dr. John G. Trump to assess what remained. Trump, a specialist in high-voltage engineering who had helped develop Van de Graaff generators for medical use and radar research, spent 3 days examining Tesla's papers, equipment, and the mysterious package the inventor had left in another hotel's vault years earlier. The vault package carried a note in Tesla's handwriting claiming it contained a prototype worth $10,000, with warnings that opening it incorrectly would trigger an explosion. Trump, accompanied by hotel officials and FBI observers, carefully unsealed the package. Inside sat a Wheatstone bridge, a mundane device for measuring electrical resistance that every electrical engineer owned. It was standard laboratory equipment, worth perhaps $20, certainly not a death ray prototype. Trump's report to the FBI was clinical and dismissive. Tesla's papers, he wrote, were primarily of speculative, philosophical, and somewhat promotional character, and did not include new, sound, workable principles or methods for realizing such results. The teleforce weapon, Trump concluded, was not a threat to national security because it didn't exist. But Trump's assessment told only part of the story. While he examined Tesla's papers, real death ray research was accelerating in Nazi Germany, pursued by scientists who had no connection to Tesla, but had independently arrived at similar conclusions about particle beam weapons. Professor Ernst Schiebold, a German mineralogist and X-ray specialist from Leipzig, approached Reich Marshal Erhard Milch of the Luftwaffe in April 1943 with an audacious proposal. In the wake of the devastating defeat at Stalingrad, with Allied bomber formations systematically destroying German cities, Schiebold offered a technological trump card, an X-ray cannon that could disable or kill bomber crews at altitude. The concept was theoretically sound. Schiebold understood that conventional death rays faced an insurmountable physics problem. Energy is dispersed with distance following the inverse square law. To deliver lethal energy at several miles required outputs equivalent to entire power stations. But Schiebold proposed a different approach: concentrated hard X-rays generated by a particle accelerator focused into a narrow beam by a beryllium mirror aimed directly at aircraft cockpits. The plan was not to destroy aircraft structurally, but to irradiate the crews. High-energy X-rays penetrated aluminum fuselages easily. Sufficient dosage would cause immediate incapacitation or death. Even sublethal exposure would disorient pilots and navigators, forcing them to abort their missions. Bombers, expensive and scarce, would fall into anti-aircraft range where conventional flak could finish them. Milch, desperate for solutions, approved immediate funding. By June 1943, construction began at Gross Ostheim, a military airfield south of Frankfurt. The location was strategic, positioned along the main Allied bombing corridor to Frankfurt and central Germany, but isolated enough for secret research. Schiebold's team requisitioned a 1.2 million-volt high-voltage X-ray apparatus, originally intended for a Hamburg hospital, installing it in a specially constructed hangar. The device that emerged was unlike anything in conventional physics. A particle accelerator stood vertical, the electron beam aimed upward. Beneath the beam exit sat a parabolic beryllium mirror, its surface precision ground to focus X-rays. At the mirror's focal point, 9 beryllium rods arranged in a bundle served as the anode. The entire assembly was steerable, mounted on a platform that could track aircraft. When energized, the system would accelerate electrons to relativistic velocities, smash them into the beryllium target, and generate a focused cone of hard X-rays. Simultaneously, Norwegian physicist Rolf Widerøe developed a parallel system in Hamburg. Widerøe, working under contract for the Luftwaffe through his position at the electronics firm Brown Boveri, designed a 15 MeV Betatron specifically for Siebold's project. The Betatron, a circular particle accelerator that used magnetic fields to accelerate electrons, could generate significantly higher energies than conventional X-ray tubes. By November 1943, Widerøe had completed the Hamburg device and began planning even larger installations, a 200 MeV Betatron, then experimental stations at Gross-Ostheim for weapons testing. The engineering was elegant. Unlike the massive cyclotrons being developed for the Manhattan Project, Betatrons were compact, efficient, and could be manufactured relatively quickly. German industrial firms, including Siemens and the Philips subsidiary Valvo, provided components. The project's security classification exceeded even the V-weapon programs. Records refer to it only as Dr. Siebold's Institute, or the Research Center of the Air Force Gross-Ostheim. Personnel rotated between the site and Leipzig on 2-week intervals to maintain secrecy. The nearby airfield remained deliberately unused from early 1944 until September, ensuring no unnecessary attention from Allied intelligence. Then, something strange began appearing in Allied intelligence reports. Starting in December 1943, American bomber crews flying near Frankfurt reported inexplicable electrical failures. Engines would cut out simultaneously, instruments would malfunction, and radio systems would fail. The phenomena occurred consistently in the same geographic area, a 10-mile zone north of the main river, approximately at Gross-Ostheim's coordinates. The incidents were sporadic but alarming. On December 6, 1944, the U.S. Military Intelligence Service commenced Research Project 1217, investigation into German possible use of rays to neutralize Allied aircraft motors. A classified report titled "Engine Interference by Electromagnetic Disturbances" documented multiple cases of what pilots described as freakish interference that couldn't be explained by known German radar or radio systems. A top-secret report to Wright Field, Dayton, Ohio, referenced OSS discussions about a German installation near Frankfurt using some form of directed energy against aircraft. But the effects were inconsistent. Some formations passed through the area without incident, others experienced multiple failures. No aircraft were actually shot down, though several were forced to abort missions due to engine trouble. German records captured after the war revealed why. Siebold's X-ray cannon worked, but barely. The 1.2 million-volt system could generate lethal X-ray doses, but only at extremely close range. Calculations showed that to achieve incapacitating radiation levels at 20,000 feet altitude required power outputs that the system couldn't sustain. The effects Allied crews experienced were secondary. The intense electromagnetic fields generated during the operation interfered with magnetos and electrical systems, but didn't produce the intended lethal radiation. By mid-1944, Siebold's team installed the 15 MeV Betatron Widerøe had designed, hoping higher energies would solve the range problem. The new system, manufactured by CHF Mueller & Company, produced significantly harder X-rays. But physics remained unforgiving. To kill or incapacitate at bomber altitude required dosages measured in thousands of Röntgens. Delivering that energy through miles of atmosphere, even with perfect focusing, demanded power plants, not portable generators. The project continued nonetheless, driven by desperation as Allied bombing intensified. By late 1944, Siebold had expanded operations, proposing even larger installations, but reality was closing in. Allied air superiority made outdoor testing impossible. Material shortages delayed component manufacture. Personnel were reassigned to more practical defensive weapons. In February 1945, Dresden was firebombed. Wideroo's laboratory, containing the original 15 MeV Betatron and extensive documentation, was destroyed. Wideroo personally led a salvage team into the ruins, recovering the device and transporting it west ahead of the advancing Soviet army. On April 14, 1945, he delivered the apparatus to American forces at Berggrub, where it was taken into custody by General Patton's Third Army. Meanwhile, at Gross-Ostheim, Siebold's installation faced a different fate. As American forces approached Frankfurt in late March 1945, the order came to evacuate. The X-ray cannon was partially dismantled, key components destroyed to prevent capture. Siebold attempted to relocate the operation, but the collapse of the German transportation system made this impossible. When American troops secured the airfield in early April, they found the installation abandoned, the massive X-ray apparatus sitting silent in its hangar, its beryllium mirror scorched from testing. American intelligence officers examining the site recognized immediately what they'd found. The technical sophistication was impressive, the theoretical foundation sound, but the system was fundamentally impractical. To work as intended, Siebold's cannon needed to be 20 times larger, consuming power equivalent to a medium-sized city, requiring cooling systems that didn't exist, and generating radiation that would kill the operators before it reached enemy aircraft. The captured equipment went to Wright Field for analysis. The Betatron Wideroo had delivered was disassembled, studied, and eventually became the basis for American particle accelerator research in the late 1940s. The technical papers Siebold had accumulated, detailing 3 years of research into focused radiation weapons, were classified and buried in military archives. But Germany wasn't the only Axis power pursuing death rays. In Japan, parallel research had produced even more ambitious results. Admiral Isoroku Yamamoto, commanding the combined fleet, understood that Japan faced an impossible strategic problem. American industrial capacity would eventually produce overwhelming naval and air superiority. Japan needed technological breakthroughs, weapons that could level the playing field. In 1940, he authorized research into Tesla's particle beam concept, assigning the project to Dr. Yoji Ito of the Naval Technology Research Institute. Ito had spent years in Germany studying magneton development and particle physics. He understood immediately that Tesla's design was impractical. The power requirements for a Tesla-style particle beam exceeded Japan's entire electric grid. But Ito saw an alternative: microwaves. Japan already possessed advanced magneton technology from radar research. By scaling up magneton output and focusing the beam, perhaps they could create a weapon that disrupted electronics or caused physiological effects in enemy personnel. The project, codenamed Kugo, proceeded through 1941 and 1942. Ito assembled a team including physicists Maso Kotani and Sin Ichiro Tomonaga, both of whom would later win international recognition for theoretical physics. Their approach was methodical. Rather than attempting to kill outright, the Kugo system would emit high-power microwaves at frequencies that interfered with human cognition and motor function. Exposure to intense microwave radiation caused disorientation, nausea, and, in extreme cases, internal heating of tissue. By 1943, Ito had constructed a prototype. The device consisted of a large magnetotron generating wavelengths in the centimeter range, powered by capacitor banks, focused through a parabolic reflector. In testing against animals and, disturbingly, prisoners, the system demonstrated definite effects. Exposed subjects showed immediate behavioral changes, confusion, inability to coordinate movement, and symptoms consistent with microwave heating of brain tissue. But like the German programs, Kugo faced insurmountable practical problems. The system's effective range was measured in meters, not miles. Power requirements limited operation to a few seconds before components overheated. The focusing array was fragile, the aiming system crude. As a defensive weapon against amphibious assault, it might work. As an anti-aircraft system, it was useless. Japanese military leadership, facing catastrophic losses across the Pacific, eventually redirected resources to more conventional weapons. By 1944, Kugo existed only as a proof of concept, a fascinating failure that demonstrated microwaves could affect human biology but couldn't be weaponized with available technology. When MacArthur's forces occupied Japan in 1945, they found extensive documentation of the Kugo program. The technical papers were seized, classified, and sent to the United States along with other Japanese military research. Like the German particle beam weapons, the Japanese microwave research disappeared into classified archives, too sensitive to acknowledge, too impractical to develop further. All of which brings the story back to Tesla's hotel room and John Trump's assessment. Trump's report concluded the death ray didn't exist, but he was wrong on a technical level. Multiple research programs across 3 continents had successfully demonstrated directed energy effects. Matthews killing an engine at 45 feet, Shebold disrupting aircraft systems at 10 miles, and Ito incapacitating test subjects at close range. The death ray existed, it just didn't work. The physics was insurmountable. To deliver lethal energy at tactically useful ranges required either massive beam power, which demanded city-scale power generation, or perfect focusing, which no known technology could achieve. Matthews' demonstration worked because he was targeting a magnet at close range, a system exquisitely vulnerable to electromagnetic interference. Shebold's X-ray cannon affected aircraft systems because intense fields disrupted magnetos, not because the X-rays reached lethal intensity. Ito's microwave weapon worked at arm's length but couldn't project beyond a few meters. Tesla understood this. His insistence on particles rather than rays, his emphasis on vacuum systems and electrostatic acceleration showed a sophisticated understanding of the inverse square law. His proposed solution, the open-ended vacuum tube with air jet seal, was theoretically brilliant but practically impossible. No turbine could maintain sufficient vacuum against atmospheric pressure while allowing particles to exit. The air jet seal would itself disrupt the particle beam. Yet the governments of Britain, the United States, Germany, and Japan all invested substantial resources chasing the same phantom. Why? Because the strategic implications were too significant to ignore. A weapon that could disable aircraft at a 100-mile range would render conventional air power obsolete. The side that possessed such technology would dominate global warfare. Even a small probability of success justified a significant investment. And the inventors, from Matthews to Tesla to Shebold, were sufficiently credible that complete dismissal risked catastrophic intelligence failure. After the war, John Trump's assessment stood as the official conclusion. Tesla's death ray was science fiction. But quietly, military research continued. The captured German Betatrons informed American particle accelerator development through the 1950s. Japanese microwave research contributed to understanding of directed energy effects. Tesla's theoretical papers, finally released from the Yugoslav Museum in the 1980s, showed remarkable prescience about particle beam physics. The Strategic Defense Initiative, Reagan's Star Wars program of the 1980s, resurrected death ray research at a scale that would have astonished Tesla. Particle beam weapons, laser systems, and microwave emitters all received billions in funding. Some worked after a fashion. The technology had finally caught up to the theory. But by then, intercontinental ballistic missiles had rendered the whole concept strategically obsolete. The weapons that might have changed World War II arrived 40 years too late. In 1952, Sava Kosanovic finally succeeded in having Tesla's papers returned to Yugoslavia, where they went to the Nikola Tesla Museum in Belgrade. The documents John Trump reviewed were not the complete set. Critical papers, the ones Kosanovic removed that first morning in January 1943, had vanished into Yugoslav government archives. When those papers were finally examined in the 1980s, they contained extensive mathematical derivations for particle acceleration, vacuum system design, and energy focusing. Whether they represented a workable weapon or Tesla's final promotional materials remains debated. Rolf Wittero, who survived the war and became a successful physicist in Switzerland, wrote extensively about his wartime research. His autobiography, published decades later, confirmed the Gross-Ostheim project, but minimized his involvement, claiming the military applications were peripheral to pure research. Documents captured by Allied intelligence tell a different story, showing Wittero deeply integrated into weapons development, his name appearing on every major memorandum about the Death Ray program. Ernst Schiebold became a professor in East Germany after the war, teaching material science at Magdeburg. He never spoke publicly about Gross-Ostheim. His published research focused on industrial X-ray applications, non-destructive testing of metal components, work that seemed impossibly mundane for someone who had attempted to build a weapon to shoot down aircraft with radiation. Harry Grindle Matthews died forgotten, his death ray dismissed as a sophisticated fraud. But one of the Air Ministry observers at his 1924 demonstration, engineer Harry Wimperis, went on to become the RAF's Director of Scientific Research. In 1935, Wimperis commissioned Robert Watson Watt to investigate whether electromagnetic energy could disable aircraft. Watson Watt concluded it couldn't, but suggested the same principles could detect aircraft at long range. The technology Watson Watt developed became radar, the weapon that actually won the Battle of Britain. The death ray that failed led directly to the technology that succeeded. Dr. Yoji Ito returned to academic physics after the war, his Kugo research buried in classified files. But microwave effects on human tissue became a recognized phenomenon, studied extensively during the development of microwave ovens and radar systems. The frequencies Ito had investigated proved capable of causing tissue heating and neurological effects, validating his research even as the weapon concept remained impractical. And John Trump, whose dismissive assessment had officially closed the death ray chapter, went on to pioneer cancer radiotherapy using high-voltage X-rays, the same technology Schiebold had weaponized. Trump's medical generators delivered focused radiation that killed cancer cells while sparing surrounding tissue, using principles identical to what the Germans had attempted at Gross-Ostheim. The death ray, reimagined as a healing tool, finally fulfilled its potential. The ultimate irony was that directed energy weapons did become practical, but not as death rays. Lasers, developed in the 1960s using principles unrelated to Tesla's particles or Schiebold's X-rays, provided the focused energy projection earlier inventors had sought. Modern directed energy systems, including the U.S. Navy's laser weapon system deployed in 2014, can disable aircraft and missiles at tactically useful ranges, but they work through thermal heating, burning through components rather than radiating crews, and require enormous power systems that make them viable only on large ships or fixed installations. The death ray that Tesla, Matthews, Schiebold, and Ito pursued, the instant incapacitation weapon that would make war obsolete, never materialized. The physics that defeated them remains unchanged. Energy disperses with distance. Focusing requires impossible precision. Power generation imposes hard limits. No amount of engineering brilliance can circumvent fundamental physical laws. Yet the pursuit continued through 3 decades, consuming brilliant minds and substantial resources, driven by the tantalizing possibility that someone, somewhere, might succeed. In laboratory demonstrations lasting seconds, under carefully controlled conditions, the death ray worked. That was enough to justify the chase, even as the impossibility became increasingly obvious. Harry Grindle Matthews' engine stopped 45 feet away. Ernst Schiebold's X-ray cannon disrupted aircraft systems 10 miles distant. Yoji Ito's magnetotron induced disorientation at arm's length. Nikola Tesla's particle beam existed entirely in theory, though his mathematics were sound. Each represented genuine achievement at the edge of possibility. Each failed to bridge the gap between demonstration and deployment. John Trump examined Tesla's papers in January 1943 and concluded the death ray was speculative fiction. 6 months later, at Gross-Ostheim, Schiebold's team activated their X-ray cannon and watched Allied bombers' instruments malfunction at altitude. Both assessments were correct. The weapon existed and didn't exist simultaneously, real enough to affect physical systems, too impractical to deploy operationally. The death ray programs ended not because they were impossible, but because they were unnecessary. Conventional weapons, refined through relentless engineering and mass production, proved adequate for victory. The P-47 Thunderbolt's 8 machine guns, the B-29's incendiary bombs, and the atomic bombs at Hiroshima and Nagasaki all delivered the decisive force that death rays promised but couldn't provide. War was won through overwhelming material superiority, not exotic physics. In university physics departments today, professors occasionally assign death ray calculations as thought experiments. The math is straightforward. Calculate the energy required to disable an aircraft at X distance, factor in atmospheric absorption and beam dispersion, and determine the power generation needed. Students arrive at the same conclusion every time. Possible in theory, impractical in execution, requiring technology decades beyond current capability. Which is precisely what Tesla, Matthews, Schiebold, and Ito and dozens of other inventors discovered between 1923 and 1945. The death ray worked for a few terrifying seconds in isolated demonstrations, then physics reasserted itself and the dream collapsed. The mad scientists weren't mad, they were just slightly too early, pursuing the right concept with inadequate technology. Brilliant enough to demonstrate the principle, but unable to overcome the limitations. The documents John Trump examined in room 3327 of the New Yorker Hotel contained the final calculations of a man who had revolutionized electrical engineering but couldn't defeat the inverse square law. Tesla knew in his final years that his teleforce weapon wouldn't work as advertised. The technical papers were promotional material, attempts to secure funding for a concept he understood was beyond reach. But he couldn't admit failure, not after decades of grandiose claims, not while living on credit in Manhattan hotels, sustained by nothing but reputation. The death ray died with Tesla in January 1943, but the dream persisted, resurrected periodically whenever technology seemed to make the impossible achievable. In the 1980s, Reagan's Strategic Defense Initiative. In the 2000s, the Air Force's Airborne Laser Program. In the 2010s, the Navy's shipboard laser systems. Each represented the same fundamental pursuit, projecting energy over distance to disable targets without physical projectiles. Each discovered the same fundamental limitation. Physics imposes costs that can't be avoided. Energy disperses. Power generation scales with the desired effect. Range trades against lethality. There is no free lunch, no breakthrough that circumvents conservation of energy. The death ray that could have won World War II, that Tesla promised and Matthews demonstrated and Siebold weaponized and Ito tested remains theoretical. It works beautifully in laboratories and perfectly on paper, but the gulf between theory and practice, between seconds and sustained operation, between feet and miles, proved insurmountable. The mad scientists weren't mad, they were just ahead of their time by approximately forever. The thunder of 8 synchronized Browning machine guns proved more effective than any particle beam. The fireball over Hiroshima delivered more destructive power than any X-ray cannon could generate. Conventional weapons, refined and mass-produced, overwhelmed exotic physics. The side that won wasn't the side with death rays. It was the side that built more aircraft, more bombs, more ships, more of everything. 79 years after Tesla's death, his technical treatise on teleforce sits in the Belgrade Museum, mathematically sound, physically impractical, a monument to brilliant failure. The death ray existed for seconds in Matthews' laboratory in 1924, for minutes at Gross-Ostheim in 1944, for the duration of Ito's tests in 1943. Then physics switched it off, permanently, and war continued with conventional weapons that actually worked.